Hello, welcome to any community. In this particular video, we are going to discuss the simplest method of axis identification. So this is one of the important method which will be helpful in the electrocardiogram to know about the electrical axis. Of course, this can be taken for the atrial events. This can be taken for the ventricular events also. So, which is helpful in determining the normal electrocardiographic uh, events as such. Whenever we think about the axis as such, so this is actually determined by the modified Einthoven's triangle. Einthoven's triangle, it is the triangle which is being derived from the electrocardiographic leads as such. This will be the nature of a axis wheel or the hexaxial reference system. So axis in the sense it is looking like the 360-degree circle. That's why it is being named as axis wheel, and it is being named hexaxial reference system means, so here all these frontal plane leads are being used. That is lead 1, lead 2, lead 3, AVR, AVL and AVF, they are being used. Hence, this is being named as hexaxial reference system. When you think about the hexaxial reference system, so here the positive pole of the lead 1 is said to be at 0 degree. The positive pole of lead 2 is said to be at plus 60 degree. The positive pole of lead 3 is said to be at plus 120 degree. Positive pole of lead AVL is said to be at minus 30 degree. And positive pole of lead AVF is said to be at plus 90 degree. Whereas the positive pole of lead AVR is said to be at minus 150 degree. As such, the normal electrical axis, when you say it's a normal electrical axis, that is, if the axis lies between minus 30 to plus 110 degree, which is being depicted by the blue line, that is indicative of a normal electrical axis. If the axis lies between plus 110 to plus or minus 180, then it is said to be right axis deviation. And if the electrical axis lies between minus 30 to minus 90, which is being depicted by light green arrow, that is being said to be left axis deviation. There are specific conditions where we may expect right axis deviation, for example, right ventricular hypertrophy, etc. And you may expect left axis deviation in case of left ventricular hypertrophy, etc. In that particular situation, we are going to observe the axis deviations. So the query or question to most of the students is to identify how to draw the axis V, that is the electrical axis. So here the electrical axis refers to the ventricular axis only. Of course, there are atrial axis can be drawn or septal axis can be drawn depending upon the, what do you say, that the nature of a direction of the vector as such. Now we are going to know about the axis identification. Before axis identification, we need to know about the total algebraic sum of the deflections of that particular electrocardiographic strip as such. So here there is an ECG that has been taken. So here the lead 1, lead 2, lead 3, lead AVR, lead AVL and lead AVF. The algebraic sum of the QRS deflections that is being taken. So here when you think about the lead 1, the positive pole, that is the deflection is up to 1, 3 plus 5 plus 2, that is almost 10 or 11, 10 plus 10. Whereas the minus, that is around the 2 degree as such. So that is 2 small squares. So the total algebraic sum of this particular deflection in lead 1 will be plus 8. Whereas lead 2, see this, it is around plus 4, the positive deflection, and minus 1. That is, the S wave is of minus 1. So the total algebraic sum of this particular deflection will be plus 3. Whereas the lead 3, whenever if you think about the minus aspect, that is around the minus 8, whereas the upward deflection, that is showing the plus 4. That is, total algebraic sum of this particular ECG strip will be minus 4. Then lead AVR. Think about it, it is around the minus 8 and plus 2. That is, total algebraic sum in AVR of QRS deflection is minus 6. Whereas AVL, look into this, as such the upward deflection, that is showing the plus 7. Whereas the downward deflection, that is negative deflection, that is around minus 3. The total algebraic sum of AVL is plus 7 minus 3, that is plus 4. Whereas AVF, whenever if you think about the AVF, the upward deflection is around plus 5 and it is having no negative deflection, that is 0. So here the algebraic sum in this particular occasion will be plus 5. To summarize, lead 1 around plus 8, lead 2 around plus 3, lead 3 around minus 4, lead AVR around minus 6, lead AVL around plus 4, and lead AVF, that's around plus 5. Whenever if you look into the axis identification, any two leads can be taken. Lead 1 and lead 2 can be taken. Lead 1 and lead 3 can be taken. Lead 1 and AVR can be taken. Lead 1 and AVL can be taken. Lead 1 and AVF can be taken, or any other lead 2 or AVF can be taken. Like that, any two leads can be taken to apply this specific rule. Whenever, for example, here we are going to take lead 1 and AVF. So this is the ECG strip. That's what we are observing from the past examples in the previous slides. This is what we can say the axis wheel. If you take the lead 1, that is here, this is being considered to be lead 1. And this is considered to be lead AVF. Here what we are going to note about the same thing, that is we are going to depict in the ECG picture. That is, here we have drawn lead 1, that is the horizontal green line, and the AVF, that is the vertical green line we have drawn. So, and we have noted the deflections. Lead 1 is having plus 8 and AVF is having plus 5. So here we are going to depict the lead 1 as plus 8 and lead AVF around plus 5. So we are going to draw the perpendiculars, which is being depicted by the purple line. So that will be meeting in the hexagonal reference system. And that particular meeting point should be, there should be a line which should be drawn from the center of the hexagonal reference system to this particular meeting point. And the angle that will be taken from the lead 1. So here in this particular example, the electrical axis of this particular ECG strip will be plus 30 or plus 35. This is how the axis is being identified. Let us take one more example. Instead, 1 and AVF, here we are going to see lead 2 and lead 3. Lead 2, that's showing the +3, and lead 3 that is showing +-4. So when you think about the drawing, if you draw this particular what do you say, that the summations in the depicted line, this will be leading to the same way, that is around the +30 or +35 degree that will be coming. This is how the electrical axis that will be drawn. That is any two leads that can be taken here. So to sum up, axis identification, frontal plane leads are being taken. That is lead 1, lead 2, lead 3, AVR, AVL, and AVF. Any of the two frontal plane leads are being taken to identify the axis as such. This is called third rule of axis identification. Any two frontal plane leads that are being taken, as we have discussed earlier, then it is actually helpful in determining the atrial axis, ventricular axis, septal axis, etc. that can be drawn. By that, we are even able to identify the axis deviations also, whether it is left axis deviation or right axis deviation. Dear AMA community, that's all for today. What are the major key takeaways from today's discussion mentioned in the comment box below? And what is the one video you'd like to hear in the coming days in this particular channel? Mention in the comment box below, and spread this particular video to maximum number of true Nidana learners so that we can make a huge movement out of this particular small message. That's all for today. Something more in the next video. Thank you.